Okay, Calculus 3 students, hey there. I'm going to cover as many problems as I can in the chapter 12 homework part 3 or the final part. You can call it whatever you want to call it. Part 3, the final part. I don't want this video to become outrageously long, and I'm probably going to have to pause the video and come back to it and take breaks and stuff like that because, when you're doing stuff at home. There's stuff happening with relatives, my dog. So, this is not exactly a nice, peaceful, quiet work environment. And this is not a library, so there's only so much I can do. And My office is actually a corner of the den, which has a lot of family activity. So it's difficult to make very long videos because there's a lot of interruptions going on around here. Okay. So, but I'll do what I can do. Let's cover a sample. Let's cover an interesting sample of problems from this section. Obviously, I'm not going to do every problem for you guys. I will do a sample of different problems so that you get a general idea of what this particular homework assignment is all about. And there's one problem in particular that I want to do for you. I think it's problem 109, where I can show you a really interesting way of solving the problem that's not based on calculus. It's actually based more on computer programming. But I think it's going to be very interesting. So let's start with problem number 1, okay, which is pretty simple and basic. Okay, hold on. I have to talk to my dog here. Okay, so you have to chill out. my dog is looking for my attention. You need to chill out. Okay. Suppose n is a vector normal to the tangent plane of the surface f of x and y and z is equal to 0 at a point. Okay. How is n related to the gradient of f at that point? They're actually going to be parallel to each other. They may not have the same magnitude. The magnitudes could be different, but they're going to be parallel because they're both perpendicular to the surface. So you would say, let me see, C, the gradient of f is a multiple of n. That should be correct. Okay, so for any point P of A and B and C on the surface, f of x and y and z is equal to 0, the tangent plane has, I believe the upside down triangle is pronounced nabla, or is it nambla? I think it's nabla. This is the symbol of the gradient. So gradient f of A and B and C as its normal vector. Therefore, the gradient of f is orthogonal to the level surface f of x and y and z is equal to 0 at all points of the domain at which f is differentiable. Since both the gradient of f and n are orthogonal to the surface f of x and y and z is equal to 0, the gradient of f must be a multiple of n. The only thing I have a slight issue with, it says here, therefore the gradient of f is orthogonal to the level surface f of x and y and z is equal to 0 at all points of the domain at which f is differentiable. I would argue, I have a little bit of an issue with that. It's orthogonal to the surface at that particular point. That doesn't mean it's orthogonal to the surface at every single point in the domain of the function. I would have to think about that. I think maybe that part is a little bit off, but okay, so you get the general idea. You get the general idea. Okay, so number 2, write an equation for the plane tangent to the surface f of x and y and z is equal to 0 at the point ABC. Let me see here. So we need the partial derivative with respect to x and y. Okay, I believe it's going to be option D. Actually, okay, hold on one second. So, write an equation for the plane tangent to the surface. Oh, you know what? Because we're dealing with three variables here. Well, see, this one's a little tricky. It's either going to be C or D. Um, this looks like a very good candidate, although it's a choice between C and D because they're both actually correct. Z is equal to the partial derivative of the function with respect to x at the point a, b. Oh, you know what? It can't be D. And the reason it can't be D, okay. The reason it can't be D is because here we're only considering A and B. So A is a specific value of X and B is a specific value of Y. Well, what about Z? You can't just ignore Z. This is a slightly tricky question, but yeah, it's going to be C. Okay, we're taking the partial derivative of the function with respect to X, evaluated at the point ABC, X minus A. You do the same thing for the Y coordinate, you do the same thing for the Z coordinate, and it's going to be equal to 0. That should be correct. Okay, so that's a little bit tricky. It's subtle. D is very tempting, and if we were dealing with a function f of x and y, the answer would be D. But because we have three variables here, okay, f is a function of three variables. In order to find those partial derivatives, the partial derivatives are themselves functions of three variables. Remember, A is a specific value of x, B is a specific value of y, C is a specific value of z. You need three variables to define the function, but you also need three variables or three arguments to define these partial derivatives because they too are functions of three variables. That's a little tricky. You have to really think about that a little bit. Okay, let's move on. Number 3, write the approximate change formula for a function z is equal to a function of x and y at the point AB in terms of differentials. Okay, so we're going to rule out here one second. We're going to rule out C and D. It's definitely not C and D. Why isn't it C and D? Well, because here I have delta z. Delta z is equal to whatever, and delta z is equal to whatever, okay? So here, delta z does not represent an infinitely small quantity, whereas dz represents this really, really, really tiny, infinitesimally small quantity. Okay, so this is going to be, let me see. It's a choice between A and B, and I have to think about this carefully. So the change in z is equal to the partial derivative with respect to x of AB plus the partial derivative with respect to y, AB, plus f of A and B. This would actually be, okay, it's going to be option B. The reason it's not option A actually gives you the new value of z, which is not really what they're asking for. They're asking for, well, let me see. Hold on one moment. Let me think. They're not asking for the value of z. They're only asking for the change in z. dz is not the new z value. It's the change in the z values, actually. So it should be option B. Okay, again, you have to think about what they're asking for. So if they were asking for the z value, yes, you would have to you have to add to the equation f of a and b in order to get the actual z value. They're not asking for the z value, they're asking for the change in the z value, which means you don't include f of a and b as you do in choice A. Does that make sense? I hope it makes sense. Again, you have to think about what they're asking for, okay? Okay, problem number 4. Find an equation of the plane tangent to the following surface at the given point. Okay, so here we go. 5xy plus 4yz plus 6xz minus 60 is equal to 0 at the point x is 2, y is 2, and z is 2. Okay. So let's see. Partial derivative of f with respect to x. With respect to x, let's see, 5y plus, okay, 4yz from the point of view of x, that's a constant, so the derivative is going to be 0. And let's see, 6z. Yeah, I think, okay, I'm just going to define it that way. There are different ways to define things in Mathematica, okay? And the partial derivative with respect to y is going to be 5x plus 4z and 6xz from the point of view of y. This is going to be a constant, and of course minus 60 is always a constant. Okay. And the partial derivative of f with respect to z is going to be 4y plus 6x. Okay. So then we're going to have, now be very careful here. Okay, so this is not a calculus issue. This now becomes a Mathematica issue. I am using the variables x, y, and z here, right? I am using the variables x and y and z to define my partial derivatives. Okay, terrific. However, that means in the formula, in the equation of the tangent plane, I'm not going to be able to use those variables because otherwise I'm going to have some problems. All right. Whew. Excuse me. That was a big yawn. Okay, so I can't use those variables again to define my tangent plane because if I do, I'm going to have problems. All right. So fx times capital X, I'm going to use a capital X, an uppercase X, minus 2 plus fy, capital Y minus 2, plus fz, capital Z minus 2. And x is 2, y is 2, z is 2. Okay, so we need to clean this up a little bit. Expand it, traditional form. Okay? So what we have, now see the thing is if I had used lowercase x, lowercase y, lowercase z, okay, this entire thing, I think, would expand to 0, okay? Because 2 minus 2 is 0, 2 minus 2 is 0, 2 minus 2 is 0. I'll show you. That's not going to be pretty. Okay, so let's use lowercase variables. Right, and it's not really wrong. We know that 0 is equal to 0. Duh. You know, it's sure 0 is equal to 0. I mean, that's pretty simple, right? But that's not what we're looking for. We're looking for a more general equation. We're looking for a more general function that describes the behavior, that describes the local behavior of the function near the point 2, 2, 2. So sure, you could say 0 is equal to 0. That's kind of a smart-ass answer, but that does not describe the local behavior of the function near the point 2, 2, 2. And that's the whole point of finding the equation of the tangent plane. You're looking for, you're interested in the local behavior of the function near 2, 2, 2. Okay, this is something they do in science all the time. Okay, it's called linear. It would be easier to write this on a whiteboard, but I'm going to do the best I can. I'm writing with my trackpad. It's a little weird. It's called linearization. Okay, 1 second. Linearization. Okay? So you're taking a nonlinear function and you're trying to linearize it near a point. Why? Because linear functions are easy to work with. They're easy to analyze. And that's the whole logic behind it. Okay? Okay. So this isn't going to work. We need to use different variables. X, uppercase X, uppercase Y, uppercase Z. And that should do the trick. 20, but they're looking for, Pearson wants you to use lowercase letters, okay? 22x plus 18y plus 20z minus 120 is equal to 0. That should be correct. Okay? Very good. Okay, this is similar. Let's see. Find the equation of the tangent plane to the given surface at the indicated point. Okay, so they're looking for an equation that's equal to 0, I believe. So let's see what we have. Okay, so clear fx, fy, fz. I am clearing the definitions of these values because I want to reuse them in the next problem. Okay, terrific. So the partial derivative with respect to x, that's really easy, 2x. The partial derivative with respect to y is 2y, and the partial derivative with respect to z is negative 2z. So that's really easy. Okay. So then we're going to have fx times x minus 6 plus fy times y minus 5 plus fz times z minus 7 is equal to 0. Oh, okay. We forgot one very important thing. Replace x with 6. Replace y with 5. Replace z with 7. There we go. So I have 12 times x minus 6 plus 10 times y minus 5 minus 14 times z minus 7 is equal to 0. It looks like option C, choice C. Let's see, 12, 6, 10, 5 minus, yeah, it should be choice C. Okay. Find an equation. This is problem number 6. Find an equation of the plane tangent to the following surface at the given point. Okay, so this is going to be a little bit harder to differentiate. It's not impossible to do, but I'm going to choose to be a little lazy here, and I'm going to give this problem to Mathematica. I'm going to let Mathematica do the differentiation. Yes, I'm being lazy, but sometimes it's okay to be lazy. Not all the time, but sometimes it is. Okay. Clear fx, fy, fz. So we have a function of 3 variables, f, y, and z. And that's going to be equal to y times z times e to the power x times z minus 4. And don't worry about the equals 0. So this is a level surface that's equal to 0, but don't worry about it, okay? Right now it's not an issue. Okay, so the derivative with respect to x is going to be, the derivative with respect to y is going to be, actually be very careful here. You know what? I don't like how I defined my partial derivatives. These are going to be numbers. These are going to actually be numbers. So I'm going to use ABC. Okay, clear that. Okay. So where x is replaced with A, y is replaced with B, and z is replaced with C. Oh, sorry about that. There we go. That makes much more sense. So x, y, and z are being treated as symbolic values. A, B, and C are actually numerical values. Be very careful with that, okay? There is a difference. Now we differentiate with respect to y. And again, A and B and C are numbers. X, Y, and Z are symbolic values. X is replaced with A. B substitutes for Y. C substitutes for Z. Okay. Okay. I'm differentiating with respect to Z. X is replaced with A. Y is replaced with B. C substitutes for Z. There we go. So I've defined my partial derivatives. So the tangent plane is going to be fx. One moment. I just want to see something right over here. Okay. Okay. So then we have 0, 4, 1 times x minus 0, which is really just x, plus fy 0, 4, 1 times y minus 4 plus fz times z minus 1 is equal to 0. Expand traditional form. Okay, that's a little bit strange. What on earth happened? Derivative of f of x and... Okay, Mathematica is doing something strange. Wait a second. F of x of 0, 4, and 1. Okay, that's equal to 4. Fy of 0, 4, and 1. That's a number. Okay. Fz of 0, 4, and 1. Okay, so these are evaluating to numbers. Why am I getting... Oh, I see what's wrong. Yeah. Okay, 0, 4, 1. Okay, that looks a little bit better. And actually, I could probably do this. Replace x with little x. Replace y with little y. Replace z with little z. Whoop, with little z. Let's see, 1 second. That's purely cosmetic. That's actually a cosmetic issue. All right, I'm not going to worry about that. Mathematica doesn't seem to like what I did over there, so that's fine. Okay, so the answer that I'm getting is 4, not 4 capital X, Pearson wants you to use lowercase letters, so be careful. 4x plus y plus 4z minus 8. 4x plus y plus 4z minus 8 is equal to 0. Okay? There is probably... Well, if you wanted to make this more cosmetically attractive, I mean, you could copy and paste over here, and then you could do something like that. Interesting. Okay, so Mathematica is complaining because I'm trying to evaluate traditional form input. Let's give it a shot. I see. Okay. Yeah, I mean, it's... So all I did, guys, is I replaced my capital letters with lowercase letters. I replaced my capital letters with lowercase letters. But I mean, that's something that, that's kind of a cosmetic issue. Just remember, if your answer in Mathematica has capital letters, it's simple. When you write your answer, when you type your answer into the answer box in Pearson, just remember to use lowercase letters. And it's not a big deal, right? It's really not a big deal. Okay, so let's move on. Okay, this is actually slightly different. Find an equation of the plane tangent to the following surface at the given point. So here, guys, for number 6, notice we're given a surface. a surface equal to a constant, which is usually 0, but it doesn't really have to be 0. Okay, it's usually 0, but it doesn't have to be 0. For number 7, we're not given the equation of a level surface. This is simply a function of x and y. So here, this problem is a little bit different. Just a little bit different. It's similar, but it's a little bit different. Okay, so here I have a function. Hold on one second. Okay, so here we have a function z x y. And that's going to be 7 minus 4x squared minus 3y squared. Looks good. Okay. Excuse me. Okay, so let me just move my laptop a little bit. Let's see what we have. So here, guys, the partial derivative of z with respect to x. Well, there are different ways I could do this. Here, you know what? I'm not even going to define this as a function. The partial derivative of z with respect to x is simply going to be negative 8x. And the partial derivative of z with respect to y is simply going to be negative 6y. So what you're going to end up with is z. Okay, this part's confusing, but not really. So why are they giving, see, this is a little bit weird. Why are they giving you the z value? You're not going to use it when you figure out the equation of the tangent plane. So we can check z of 5, 3 should be negative 120. Okay, but you're not actually going to use, how can I say this? For right now, don't worry about the negative 120. You're not going to use it directly. You're not going to use it directly. You will use it, but you're not going to use it directly. So your formula, your tangent plane is going to be, well, that of course is negative 120, but for right now, it's better to think of it as z of 5 and 3 plus zx times, in this case, it's okay to use lowercase letters because zx and zy are not actually functions. They're just definitions. They're not functions, they're just definitions, the way that I'm using them in Mathematica right now, so it's okay. So that's going to be x minus 5 plus zy times y minus 3 . What? Okay, hold on one second. What's going on? Okay, let me finish the problem. Okay, let me finish the problem, and then I think I have to pause the video and find out what's happening at the other end of the house. Okay, so we'll expand it. Traditional form. Okay, hold on. So we have z is equal to negative 8x squared plus 40x minus 6y squared plus 18y minus 120. Actually, there is something really wrong with that. Why do I have quadratic terms here? Oh, I know what's going on. Wait a minute. This is not right. This is definitely not right. Okay, now I see what's happening. X is replaced with 5. Y is replaced with 3. Okay, and that doesn't... Okay, hold on a second. So I have a negative 120 is equal to negative 120. Here's the problem. I do have to use uppercase letters. Okay, that makes a whole lot more sense. Okay, so z is equal to negative 40x minus 18y plus 134. It should be correct. Okay, so I knew something. Let me explain something. I knew something was really wrong because... Oops, no, that should be... Okay. Something was really wrong here, and I'm going to tell you why. Okay, so what is the problem? Why is this the wrong answer? Well, I can tell you it's the wrong answer because the equation of the tangent plane is supposed to be a linear equation. It's a linear equation, okay? Well, we have a little problem here because these are not linear terms. These are not linear terms. Those are quadratic terms. And because they are quadratic terms, they do not belong in the equation of the tangent plane. So something was definitely wrong. Yes? I hope that makes sense to everybody. Okay, let me get rid of that. So how do we fix the problem? Again, guys, be careful. I better use uppercase X, uppercase Y. Oops. Yes, of course. And we have to do our substitution. X is replaced with 5. Y is replaced with 3. And that does make a lot more sense. Okay? So we know that the answer is negative 40x minus 18y plus 134. Okay, we're gonna pause the video. There's something happening at the other end of the house. So the joys of working from home, right? So we will continue this shortly. Let me just pause this. Pause. Okay, yeah, so yeah, my mother is 90 years old and she could be doing a little better. So yeah. Okay, so anyway, let's continue with the video and hopefully, no more interruptions. Yeah, so this is why, guys, I get a little annoyed when students email me, with a lot of personal stuff. We all have personal stuff. We all have stuff going on. And we just have to do what we have to do in spite of it. And, some people just tried to, what's the right way to say it? Some people try to carry more than they are able to carry. If you're taking 6 courses and you're taking care of 3 dogs and raising 2 children and working full time, I would say you're doing more than most people can do. Okay, so some people try to carry more than they can handle, and you have to be honest with yourself about your limitations. For some people, 2 courses a semester is all they can handle, and that's it. Personally, I would rather get 2 A's than 4 or 5 C's. If you're working full time, if you're working part time, that's a little bit different. But if you're working full time and going to school, that's extremely difficult to do. That's extremely difficult to do. People have done it, it can be done, but your health will eventually suffer because it's very, very hard to do. So that's why I get annoyed when students email me with a lot of personal problems. Yes, I feel sorry for you. I understand things are difficult, but the bottom line is, excuse me, I have to give you a grade. The grade that I give you is not based on whether or not I like you. It's not based on whether or not you're a hardworking person. Your grade is not based on whether or not you're a good person. The grade is just based on one thing, and the grade is based on how you perform on your homework, your quizzes, and your tests. That's it. You could be the nicest person in the world. You could have the best intentions in the world. You could, you could be the best, the most wonderful human being on the planet Earth. But I can't base my grade on that. The grade that you get is based on one thing, and that's how well you do on the homework assignments, the quizzes, and the tests. And that's it. So it has to be very objective. It has to be very objective. So that's why I get a little annoyed when people send me emails like, I'm having a hard time. I need a 1-week extension on the homework. I'm having a hard time. I don't understand Mathematica that well. My mom is sick. Can I take the test in 2 weeks? Sure, I feel sorry for people. They have problems, but that's not the point. The point is you have to do the work, because if you don't do the work, well, the grade that I'm going to give you probably is not going to be a very good grade. So remember, it has to be objective, guys, and I think some of you don't quite understand that. Some of you are spoiled in the sense that you're used to high school teachers that, were kind of soft and easy. Elementary school teachers, high school teachers, a lot of times they're under pressure from parents and administration to make compromises with students. College, and especially, well, college is very different. College is different. Excuse me. And I will say, when you transfer to a 4-year college, when you transfer to a regular university, okay, things are going to be even more different. Excuse me. Things are going to be really different. Like I said, elementary school teachers, high school teachers, they are often under a lot of pressure from parents and from administrators to negotiate compromises with students. I need water badly. Hold on one second. Okay, that's better. So elementary school teachers, high school teachers, they try to negotiate compromises with students because, that's their job. That's their job. They're under a lot of pressure from parents, from administrators, and that's their job. College, university, that's a whole new different ball game. A whole new different ball game. Okay, the emphasis, so in college and in a college environment, especially in a university environment, the emphasis is really on academics. The emphasis is really on academics. And I'm going to tell you right now, if you can't pull your weight in that type of environment, most of the professors will not even give you the time of day. So that's something you really have to remember as you continue with your college and university education, okay? So I'm not trying to scare students. I'm just telling students this is the world. This is the world of college. This is the world of university education. This is it, right? This is it. So if you go to a place like the University of Illinois and you tell the teacher, I'm having a hard time, can I please take the test in 2 weeks? Most of the professors will politely tell you, no way. You either take the test with everybody else on the same day as everybody else, or I am going to give you an F. And that's it. That's how the cookie crumbles, okay? Okay, so I think I said what I had to say about that, but I understand people have problems, but in spite of that, guys, you got to do the work, plain and simple, or just accept your C or your D or your F, okay? All right, let's continue. Okay, so this is very similar to what we just did. This is very similar. Okay, so let's start moving deeper into the homework because, otherwise this video is going to take all day. We could do this one. This is a triangle problem. Hold on one second. I'm looking for a very specific type of problem. Actually, we can do, well, okay, I'll tell you what. Let's do number 13. Number 13 is a little bit different from the problems we've been working on. So let's take a look at number 13. Okay, clear global everything. So what does this do? What does this actually do? The command I just entered clears all of my function and variable definitions. Okay? So let's see. We have f of x and y is equal to control 2, gives me the radical symbol, x squared, or I could do control 6, x squared plus control 6 again. Okay, sensational. And we're looking at the point -3/4. So part A says, find the linear approximation for the following function at the given point. Part B says, use part A to estimate the given function value. Okay, so here we go. Oops. Partial derivative of f with respect to x. Okay, so that's the derivative of f of x and y with respect to x. A takes the place of x. B takes the place, oops, sorry about that. B takes the place of y. Shift enter. We're going to do the same thing to find the partial derivative of f with respect to y. So this right over here is the partial derivative of f with respect to x. Let's do the same thing to find the partial derivative of f with respect to y. Fy, a and b are numbers, x and y are symbols. And there is a difference in Mathematica. For example, this is an integer. This is a symbol. 5 is an integer, z is a symbol. Okay, what if I do this? Z is equal to 5. Z is now an integer. Clear Z. What is the type of Z? Z is now a symbol. I hope you guys understand that, okay? So in Mathematica, there are different types. There are different types. What is the type of 3.02? It's a real. What is the type of hello, Mr. Lewitt? This is a string. Okay, so be aware that in any programming environment, you're going to have different types, and that's a very important concept, okay? Okay, let's get back to this. Okay, so I'm differentiating with respect to y. A takes the place of x. B takes the place of y. Okay, sensational. Okay, so L of x and y is equal to, actually, how do I want to do? Okay, so here, you know what? I'm going to use A and B. We're going to use numbers. I think we had better use numbers. AB times x minus A plus Fy times y minus b. Now here, guys, we really do need to use the value of f of a and b. F of a and b. And let's expand it. Let's expand it in traditional form. So what is the equation of the tangent plane when x is equal to -3 and y is 4? Okay, so we're going to have 4, well, let me write it like this: 4y over 5 minus 3x over 5. Actually, we could simplify that a lot. Let's do 4y minus 3x over 5. 4y minus 3x over 5. Let's see if that should be correct. It should be correct. Okay, now we're going to use part B. Well, it says here use part A, use the answer to part A to estimate the given function value. Well, that should be easy. We're just going to, let me put my cursor back into Mathematica. 4 times y minus 3 times x divided by 5, where x is replaced with -2.97 and y is replaced with 4.04. And the answer should be 5.014. 5.014, it should be correct. Okay, pretty simple. Pretty simple. Okay. Okay, here we're getting into differentials. So let me, but this is not an especially exciting problem. Hold on one second. I did see a problem here that I thought was really interesting. Okay, one second. It was actually, oh, here we go. Yes. Problem 22. Yes, problem 22 looks very interesting to me. Okay, so problem 22. So this is where we need to use differentials. Let me write that down. Oops, wait a minute. All right, hold on one second. For this problem, we need to use no. There we go. So for this problem, we're using differentials, which is almost the same as derivatives. Very, very similar. It's very, very similar, except derivatives are kind of like fractions, right? Derivatives are sort of like fractions, like, dz dx, okay? But when you're looking at a differential, you're usually looking at just one part of the fraction. You're usually looking at just one part of that fraction, okay? Okay, here we go. One second, let me just, hold on, let me pause for a moment. Okay, so let's take a look at problem number 22. The cost of a trip that is L miles long, driving a car that gets M miles per gallon, with gas costs of P dollars per gallon, is going to be the cost is equal to L times P divided by M dollars. Okay, which kind of makes sense because let me see here. So P dollars to the gallon, excuse me. Okay, excuse me. So as P increases, the cost is going to increase, obviously. M is miles per gallon. So if you have really good gas mileage, as M gets bigger and bigger, you would expect your cost to decrease. So it makes sense that P is in the numerator and M is in the denominator. And then L is the number of miles. So the formula does make sense. So as your gas mileage increases, you have a more economical car, which means the cost of the trip decreases. P is going to be the cost per gallons, and obviously that increases as you continue to drive. And L is going to be the total distance of the trip. So the formula is very logical. Okay, suppose you plan a trip of L is equal to 1,500 miles in a car that has gas mileage of 32 miles per gallon with gas costs of $3.80 per gallon. Complete parts A through D. Explain how the cost function is derived. What is the general cost for the car traveling 1 mile? The cost, type the answer using the symbols L, P, and M as needed. So this is simply going to be P divided by M, because 1 times P is P, and P divided by M, we have that from the formula, so that's pretty easy. What is the cost for the car traveling 2 miles? Type the answer using the symbols L, P, and M as needed. Well, that's obviously 2P divided by M, so that's pretty easy. What is the cost for the car traveling L miles? Type the answer using the symbols L, P, and M as needed. Well, that's just the formula that they actually gave you. And again, it's pretty straightforward and simple. Okay. Examine the units of the function determined previously. Okay, so this is easy. The units of the cost function, it has to be dollars because it's a cost function. So it's a cost function, which means that we're dealing with total costs. So the units are obviously dollars. Okay. Part B, compute the partial derivatives CL, CM, and CP. Explain the meaning of the signs of the derivatives in the context of this problem. Okay, so let's do that. So we have cost of, let's see, the function L, P, and M is equal to L times P, control divided by M. Okay. Cost L. Here, let me see. Okay, we'll do it like this. LPM is equal to the derivative of the cost function of LPM with respect to L. The cost function with respect, okay, the derivative of the cost with respect to P, LPM, is going to be the derivative of the cost of LPM with respect to P, shift enter, and then the derivative of the cost function with respect to M, LPM, is the derivative of the cost function of LP and M with respect to M. Okay. So we have to be careful here. Remember, we're going to get back symbolic values rather than numbers. We're going to get back symbolic values rather than numbers, and we do have to keep that in mind. Okay, so here, what is the derivative of the cost with respect to the number of miles? Well, put my cursor back here. LPM. That's just going to be P over M. Okay. What is, okay, the partial derivative with respect to M? It's going to be LP divided by M squared. Okay. And finally, what is the derivative of the cost function with respect to P? LPM. And that's simply L over M. L over M. Okay. Explain the meaning of the signs of the derivatives in the context of this problem. Okay, let's take a look at this. Well, we can see here as the mileage increases, the total cost is going to decrease. Okay. Let's see. As the distance of the gas cost per gallon increases, the cost increases. But if the car's mileage per gallon increases, the cost decreases. That's actually correct. If anything increases, the cost increases. This is wrong. As the distance, as the distance or the gas cost per gallon increases, the cost increases. But if the car's mileage per gallon increases, the cost decreases. Okay, it's going to be option B. Okay, option B. Part C, estimate the change in the total cost of the trip if L changes from L is equal to 1,500 to L is equal to 1,515, and M changes from M is equal to 32 to 31. And P changes from $3.80 to $3.85. Okay, so we have to use differentials for this. Okay, so let's look at our problem. Let's see. So we're going to have cost L, LPM, where L is replaced with 1,500, and let's see, M is replaced with 32, and P is replaced with $3.80. Okay. Multiplied, let's see, hold on one second. So let me make sure we're doing this correctly. So this is our starting, this is the point that we're analyzing. L is 1,500 miles, M is 32 miles per gallon, gas cost of $3.80. So okay, one second. So this is going to be 1,515 minus 1,500, okay, plus cost M of L, P, and M, where L is replaced with 1,500, M is replaced with 32, P is replaced with $3.80, times, let's see, M goes from 32, it was originally 32, so that's going to be 31 minus 32. And then the partial derivative of the cost with respect to P, LPM. L is replaced with 1,500, M is replaced with 32, P is replaced with $3.80, multiplied by $3.85 minus $3.80. So in each case, let me make sure we're doing this correctly. So we have 1,500. We're analyzing the point 1,500, 32, and 3.80. So it's minus 1,500 minus 32 minus 3.80, and that should be correct. Let's see. Okay, so I'm not, okay, why am I getting all of these unevaluated expressions? Okay, this is not good. Hold on a second. Let me use parentheses. Let me use parentheses here, guys. And hold on, one second, times, okay, plus, yeah, very strange. There we go. Okay, so the problem was I needed parentheses. I needed to parenthesize, these expressions, I needed to parenthesize these expressions. Okay, that was the issue. I needed to parenthesize these expressions. Okay. The estimated change in cost is round to the nearest cent as needed. Well, we can do that easily. Number form, take my previous answer. I want all the digits to the left of the decimal point and 2 digits to the right of the decimal point. And so my answer is simply $9.69. Why am I getting an absolute value symbol? $9.69. Okay. Okay, part D is the total cost of the trip with L is equal to 1,500 miles, M is equal to 32 miles per gallon, and the price of gas is $3.80 per gallon, more sensitive to a 1% change in L, a 1% change in M, or a 1% change in P, assuming the other two variables are fixed. Explain. Select the correct choice below and fill in the answer box to complete your choice. Okay, so for this one, guys, what I would do is I would copy and paste what I have over here. Okay, so wait, Command C. Okay, so for L, let me see. So we're just going to worry about L right now. So that's going to be, these other two are going to be 0. And this one, okay, this is going to be 1,500 times 1.01. And why is it 1.01? Because we're talking about a 1% change. A 1% change. Okay, so that's $1.78. Now, what is it going to be? There's no change in L. There's no change. One second. Oops. Okay. Let me see here. There's no change in L, and there's no change in P, but there is going to be a change in M. So that's going to be 32 times 1.01. Okay, so again, it's a change of about $1.78, but this time it's, it's going in the opposite direction. And this time, okay, there's no change in L, there's no change in M, and there will be a 1% change in the amount of money that you're spending on each gallon of gasoline. So 3.80 times 1.01. Okay. So actually, in all three cases, the change will be $1.78. Okay. In all cases, the answer is going to be about $1.78. So the answer, let me see here. It should be D. All the variables are equally sensitive to a 1% change because all of their relative changes, so we're going to disregard the signs, positive or negative, all of their relative changes are to the same degree, which is correct. Okay, that is correct. Okay, so this video is starting to get a little bit too long. I may have to split up this project into 2 videos. Let me do one problem in here that I think is especially fascinating. It's a really interesting problem. I took a look at it last night and I was like, this is really interesting. This is going to be the last problem for this video, guys. And then later on today or tomorrow, I will post another video because, I'm slowly losing my voice here, and you're probably losing your attention span. So, so it might be better to break this up into 2 videos rather than one super long video, because I'm going to lose my concentration. You're going to lose your attention span. So it's probably not a good thing. But let me do one more problem before I call it quits. Hold on one second. Got some dirt on my computer here. Okay. So I want to look at problem 109. I looked at it last night and I'm like, oh, this is such an interesting problem. It's interesting because there are a couple of different ways of solving this problem. So you can use Lagrange multipliers, okay? I think Pearson, the authors of your Pearson textbook want you to use the Lagrange multiplier method. However, you can also use Mathematica if you really understand how to use Mathematica. Either way, I mean, if you're going to use the Lagrange multiplier method, you're going to have to do some work. If you're going to use Mathematica, you're going to have to do some work. So either the math work is going to be difficult or the computer work is going to be difficult. But this is actually a difficult problem, so you're either going to have to be a very good mathematician or a very good computer programmer in order to figure out the solution to this problem. Okay, so I will let you read the textbook. You can figure out how to use Lagrange multipliers to solve this problem, but I'm going to show you how to solve this problem from the Mathematica point of view, from the computer programmer's point of view. Either way, you're going to get exactly the same answer, okay? So let's take a look at this problem. What are they asking? What are they asking here? It says here, find the maximum value of 7x1 plus x2 plus x3 plus 7x4 subject to the condition that x1 squared plus x2 squared plus x3 squared plus x4 squared is equal to 100. Now, I'm going to assume, this is perhaps a silly assumption, but I'm going to assume that they are looking for integer answers. I am going to assume that they are looking for integer answers. And actually, to be quite frank with you, it's not a totally silly assumption, because if everything's squared, if all 4 variables squared equals exactly 100, then chances are I'm dealing with a sum of perfect squares, in which case all 4 variables are going to be equal to integers. So it makes sense to assume that x1, x2, x3, and x4 should be integers, okay? So how would I use Mathematica to figure this out? Well, first of all, what is the question that they're asking me? I have a function here, okay? 7x1 plus x2 plus x3 plus 7x4. And I have to make this as big as possible, but there's a condition. And the condition is when I take the first number squared, and I take the second number squared, and I take the third number squared, and I take the fourth number squared, I'm going to have to end up with 100. Okay? So it makes sense, guys, if you think about it. What are the boundaries of this problem? Okay, so what if x2 and x3 and x4 are 0? Well, if x2, x3, and x4 are 0, x1 obviously is going to have to be 10, okay, because 10 squared is 100. And the same thing with x2. What if x1, x3, and x4 are 0? Then x2 has to be 10 because 10 squared is 100. And then what if x3 is a positive number and x1, x2, and x4 is 0, then x3 is going to be 10 because 10 times 10 is 100, and the same thing with x4. So it makes sense that none of these integers can be bigger than 10, right? So I'm going to search, and also it doesn't make sense, excuse me, it doesn't make sense that any of these numbers are negative. Okay, because if any of these values are negative, if x1 is negative, if x2 is negative, if x3 is negative, if x4 is negative, then I'm not maximizing my function. Actually, I'm going in the opposite direction. I'm minimizing my function, and that's not what I want. I want to maximize my function. Okay, so basically, I'm looking for integers between 0 and 10. I'm looking for integers between 0 and 10. So x1 is going to be an integer between 0 and 10. x2 is an integer between 0 and 10. x3 is an integer between 0 and 10. And similarly, x4 is an integer between 0 and 10. So this is going to take a little bit of Mathematica magic. Okay, let's see how we can do this. Table. Well, what does table do? What does table do? Table is simply a way to generate a list. Like k squared, k goes from 1 to 5. 1 squared, 2 squared, 3 squared, okay, 4 squared, 5 squared. Okay, very simple. Very simple, right? So what I'm going to do is this. I'm going to do table, 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 table. Why am I using 4 table commands? Because I have 4 variables. Okay, x1, x2, x3, x4. x1 goes from 0 to 10. Wait. x2 goes from 0 to 10. x3 goes from 0 to 10. And finally, x4 goes from 0 to 10. Now, because I'm using 4 table commands, I'm going to end up with a list embedded within a list, embedded within a list, embedded within another list. And that's going to be a little bit too much, okay? So what I'm going to have to do, I'm going to call this possible solutions. And I'm going to terminate this with a semicolon because I don't want to see the output. The output's going to be very large. I'm not even sure if Mathematica is going to show me all of the output. I'm going to flatten it to 3 levels. And the reason I'm doing that, something weird just happened. Hold on one second. Why? Oh, there is no, oh, I'm using the wrong command. Flatten. Okay. And if you're wondering, okay, why am I getting this weird... Okay, what does flatten do? Hold on one second. Flatten. Okay, flatten basically removes the outer list layers, the outer brackets. But this is not, hold on one second. There we go. Yeah, but something is not quite working here. Hold on one second. Oh, I'm missing a table. Okay, x1, x2, x3, x4, possible solutions. There we go. This is going to be a pretty big table. Possible solutions. 11 times 11 times 11 times 11. Yeah, and the reason is because I have integers from 0 to 10, so that's 11 numbers. So 11 times 11 times 11 times 11, I have 14,641 different possible combinations. Okay. So the next step that I want to do is I'm going to have to filter out only those values where the first number squared plus the second number squared plus the third number squared plus the fourth number squared is actually equal to 100, because that's the constraint. That is actually the constraint. Okay, so for that I would use cases. Now what does cases do? So if, let's say I have a list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to filter out only the even integers. Even, let's see, hold on. My variable will be x, even qx. Okay, so I'm taking from the list only the integers that are even. What if I wanted to take from the list only the integers that are odd? Okay, that's what cases does. So let's use it. Let's use it to find the answer to this problem. Cases, possible solutions. What variable should I use? I like the letter K. I don't care what you use. Make up a letter, okay? K, the first number squared, plus the second number squared, plus the third number squared, plus the fourth number squared is equal to 100. So we have a lot of, okay. There we go. We have a long list of possibilities here. So yeah, these are all the different possibilities. These are all the different possibilities. So the answer we're looking for is somewhere in here. The answer we want is somewhere in here. So this is what we're going to do. These are the different options that we have. I need to save this. What should I call it? betterSolutions. Okay, betterSolutions. Okay. And how long is that list? betterSolutions. So there are 59 candidates. There are 59 candidates, and I need to find the candidate that is actually going to be the best. I need to find the candidate that is actually going to be the best. So here's what I'm going to do. We need to find... So we're looking at this function. We're looking at this function, and the function is 7 times the first number, plus the second number, plus the third number, plus 7 times the fourth number. Okay, so here's what I'm going to do. I'm going to have a function f, x1, x2, x3, x4. And that's equal to 7 times x1 plus x2 plus x3 plus 7 times x4. Okay. Then I need to apply this function to all of these values and see which one is the maximum. Which one is going to give me the maximum? Okay. So to do that, I could do something like this. Okay. I could say f, well, let me see here. How would I want to do this? So we're going to have f apply. Okay, so the first, I'm going to use what's called an anonymous function in Mathematica. The first number, second number, third number, fourth number. I have to end it with the ampersand. And I'm going to apply, actually, wait a minute. No. That's not gonna work out too well. So this is a single entity. It's a single entity, but it has 4 parts. It's a single entity, but it has 4 parts. So this is what I have to do. the hash, let me see here, 1, 2, 3, 4, and we're going to map this onto betterSolutions. There we go. I have to remember to use the ampersand. There we go. Okay, not too shabby. That actually worked out pretty well. Not too shabby. So I'm going to save that in a variable. I'm going to call that betterSolutions2. Well, call it whatever you want to call it. Or you could call it, well, I'll just call it betterSolutions2. It makes sense to call it that. Okay, Shift Enter. So if I do betterSolutions2, let me see what this is going to look like. Why am I getting, hold on one second, okay, that should not be, hold on one second. Okay, one second, I want to see something. So betterSolutions2, something didn't get defined. Why didn't this get defined? That's really weird. Oh, because this is okay. I screwed up my Mathematica worksheet here. Hold on a second. So F, and then betterSolutions2 is equal to betterSolutions2 table form. Okay, so here you can see if x1 is equal to 10, the max is 70, 62, blah, 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 blah. So we're actually looking for, the maximum. We're looking for the maximum, and actually the maximum looks like it is, one second, it looks like it is, I'm looking in the right column, guys. So it looks like it's, the maximum is actually going to be this number here. It's going to be 100. We could actually find out. So what I could do is I'm going to start with maximum of 0 for k is equal to 1. K is less than or equal to the length of betterSolutions2. Let me just see one thing. betterSolutions2. Okay, so here's the value of my function. So if betterSolutions2 is greater than maximum, then let maximum be equal to betterSolutions2. Actually, this would be, this would be k comma 2. Okay, so if betterSolutions k2 is greater than the maximum is equal to betterSolutions k2. k plus plus, and then the maximum. Okay, so that's kind of, that doesn't look quite right. I want to just see something here really, really quick. Oh, whoa, wait. 2, that should be 70. Why? Oh, betterSolutions 2. Sorry, this is, okay, yeah, I know how to type. I know how to type. This should be betterSolutions 2. I have to refer to the same list. So let's start over again. So maximum, we're going to start with 0. That's really weird. But if I look, okay, so for some reason this, I don't know why I'm having an issue with this part. But if I just use my eyes and I look at these numbers here, 70, 76, 88, 62, 100. So this number here, one second. This appears to be the maximum, right? That appears to be the maximum. Let me do that again. Okay. So, yeah, it looks like all the numbers are less than 100. Although I should still be able to find that with, officially find it with Mathematica. So why this is giving me a hard time, I don't know. So maximum is equal to 0 for k is equal to 1. K is less than or equal to the length of betterSolutions 2 if betterSolutions 2, k2, is greater than the maximum. Oh, sorry about that. Maximum. Then maximum should be equal to betterSolutions betterSolutions 2 k comma 2 k plus plus. Yeah, again, I forgot to do the 2 here. That's just stupid mistake. Shift enter. So now maximum should be 100. Yeah, so I just forgot to put betterSolutions 2. That was just a stupid mistake. So the maximum is indeed 100. It is indeed 100, which I can see right over here. The maximum is indeed 100. All right, which means the maximum value is indeed 100. And, well, they should have asked you, the maximum value is 100. How do you get that value? You get the value when x1 is equal to 7. Oops, x2 is equal to 1. x3 is equal to 1. And x4 is equal to 7. So you'll end up with 7 times 7 plus 1 plus 1 plus 7 times 7, which gives you 49, right? Plus 2. Come on. What is the problem here? Plus 49, and this 49 plus 49 will give you 98. 98 plus 2, of course, is 100. And this is going to give you 100. Okay? So yeah, the reason I had issues down here, guys, was because I kept messing up. I kept confusing betterSolutions with betterSolutions 2, and that was kind of stupid. That was just a mistake. All right. So if I'm going to erase this, let's say I was going to erase this. Okay, let's start this over because the way that I did it was probably a little confusing. Probably a little bit confusing. Okay. betterSolutions. Let's look at the first answer. betterSolutions 2. Okay. And then let's look at the last answer. betterSolutions to -1. Oops, sorry. Okay. I'm going to start out with 0. I know the answer isn't 0, but I'm going to start out with 0. For k is equal to 1, k is less than or equal to the length of betterSolutions 2. Okay, I could also do the problem like this. K plus plus, which means k goes up in steps of 1, if betterSolutions 2 is greater than the maximum, then change the maximum so that it's equal to betterSolutions 2 K2. Close the if, close the for. So now maximum should be 100. So if I look at betterSolutions 2, where's 100? Where is 100? 100 is going to be right over here, and I can see that that's my maximum. So my function has a maximum value of 100 when x1 is equal to 7, x2 is equal to 1, x3 is equal to 1, x4 is equal to 7. Okay? Let's see. There we go. Okay, so I realized maybe that was a little bit confusing, but this is how a computer programmer would go about solving a problem like this. Now, I realize some of you are going to say to me, Mr. Lewitt, this is a calculus course. It's not a computer science course. Well, I'm sorry, guys, but the computer has invaded every single part of life. If you go to school and get a bachelor's degree in mathematics, you're going to have to take at least 2 semesters of computer programming. If you have a degree in mathematics, you need to know something about computer programming. Computers have invaded every single aspect of our lives, everything. So, and I can tell you right now that if you're a mathematician, you're going to have to know a lot about computers and computer programming. Because there's a tremendous amount of mathematics that is dedicated to the study of various computer science topics, from machine learning to artificial intelligence to robotics to data analysis, statistics, algorithms, recursion. The list goes on and on. So this is actually a very important topic. It's actually a very important topic. Now, if you're confused about, some of the stuff I'm doing here, email me and ask me. Like, what does a for loop do? What does a for loop do? Well, let's see. For k is equal to 1, k is less than or equal to 10, or how about 5? Print hello, Mr. Lewitt. Okay, so a for loop simply does something a certain number of times. 1, 2, 3, 4, 5. Okay, and I could certainly do something like this. ToString k. That's the symbol. This is the symbol for combining strings. And I could do something like that. Let's see if that works out. Oh, sure, because I didn't. Okay, I want to print the entire message. Print the entire message. Okay, so 5 times. Do something 5 times. What am I doing 5 times? I'm printing the number, but I have to change it to a string. Okay, this is really a string now. It's not a number. All right, this is a number, right? This is a string. So I'm doing something 5 times, right? What if I was going to do it 10 times? And instead of k plus plus, what if I did this? Let's start with 0 and go to 10. And we're going to do steps of 2. K plus 2. All right. So I'm going from 0 to 10 in steps of 2. 0, 2, 4, 6, 8, 10. Okay. So if we met, guys, if we met regularly for lectures, I could share more of this with you and explain more of this to you. It's very hard to do this through YouTube. It's very hard to do this through YouTube. But if I'm not, online teaching is not, my favorite form of teaching. I prefer to actually talk to students face to face. So if I saw you regularly for regular lectures, it would be easier for me to explain this to you. Putting this into a YouTube lecture can be a little challenging because there's a lot to talk about. But you can use Mathematica to do some really amazing things. All right, it is wonderful software, and it can really help you. It can really help you if you know what you're doing. Okay, guys, I think this video is really long enough. I will try to make another video tomorrow to cover some more of the problems in this section. There's still a lot more we have to talk about, okay? But I'm losing my voice and I'm getting a little tired here. So I think that's going to be it for today, okay? I hope this video is helpful. Sorry about my little typos. I realize I made some, when I was doing this, I got a little confused between betterSolutions, my betterSolutions list, my betterSolutions 2 list, and that created some confusing moments. So I apologize for that. Those are just typos. Those are typos, and I realize they can lead to some confusion. Sorry about that. Okay, so I think this video is long enough. Hopefully you got something out of it, and we will communicate very, very soon, okay? Take care and be well.